You do not move. You do not move. You have not moved for nearly an hour. The caterpillar on the leaf 2 centimeters from your face has no idea you exist. It has been feeding, moving, living its ordinary life at a distance that, from your perspective, is already a killing distance. You simply have not decided to act yet. That patience is not instinct in the way most people think about instinct. It is a hunting strategy refined across 100 million years, deployed by an insect that has perfected the art of becoming invisible while waiting, and then becoming lethal the moment it stops waiting. You are an assassin bug, and the way you kill is one of the most sophisticated chemical processes in the entire insect world. Cornell University has studied the Reduvidae family, the scientific name for assassin bugs, for decades, documenting over 7,000 described species spread across nearly every terrestrial ecosystem on Earth. The Smithsonian Institution holds extensive collections tracing assassin bug evolution across the fossil record, with specimens demonstrating that the core body plan of these insects has remained functionally unchanged for tens of millions of years. The same piercing beak, the same ambush posture, the same chemical arsenal. When evolution produces something this effective, it tends to leave it alone. You hatch from an egg into a world that immediately presents you as a predator. Not a grazer, not a scavenger, not a filter feeder. From the earliest nymphal stage of your life, you are a hunter, and almost everything about your body was built around the proboscis, the rigid, jointed beak folded beneath your head that is simultaneously your weapon, your injection system, and your feeding tube. The proboscis is worth understanding in detail because it is what separates assassin bugs from almost every other predatory insect. Entomologists at the Entomological Society of America have published detailed analyses of assassin bug feeding mechanics, documenting how the proboscis functions not as a simple piercing tool, but as a two-channel system. The first channel delivers a saliva mixture directly into the prey. The second channel draws the resulting liquefied tissue back out. These two processes happen simultaneously. You inject while you drink. What you inject is the extraordinary part. Your saliva contains a complex mixture of paralytic compounds and proteolytic enzymes, the same category of molecule used in industrial meat tenderizers, that begin breaking down muscle tissue, nerve tissue, and organ structure from the inside within seconds of injection. The prey does not need to be held for long. The chemistry does most of the work. The University of Exeter has studied assassin bug venom composition across multiple species, documenting how the saliva of some species contains more distinct bioactive compounds than previously known from any other predatory insect of comparable size, with individual compounds targeting different physiological systems in prey simultaneously, paralyzing the nervous system while dissolving the structural integrity of internal tissue. You dissolve your food before you eat it. You drink what was, moments before, a living insect. Is that disturbing? Consider what it requires. You are often smaller than the prey you target. You cannot overpower a caterpillar through brute force the way a mantis can. You cannot pursue a fleeing insect at high speed the way a tiger beetle can. You cannot deploy a lethal sting from a distance the way a wasp can. What you have instead is a chemical weapon so effective that prey 2 and 3 times your body size becomes manageable within seconds of contact, and a patience so absolute that the opportunity for contact almost always arrives. Let's reconstruct a hunt in full because it reveals just how different your strategy is from almost every other predatory insect people encounter. You are perched on the underside of a leaf in a garden, motionless in the late afternoon. Your coloring blends into the bark and the stem textures around you with a precision that took years of selective pressure to produce. You are not actively camouflaged in the way a chameleon actively adjusts. You simply look like what surrounds you, and you have chosen a position where what surrounds you is what you look like. A cabbage aphid colony feeds on the stem below you. You are not interested in aphids today. You are watching a caterpillar on the leaf edge 3 centimeters away, moving steadily as it feeds. You do not approach from behind. You do not circle. You simply wait for the caterpillar to move along its feeding path toward your position, because the caterpillar is going to come to you. This is the core of your ambush strategy. You position yourself along the most likely path of prey movement, and you wait for the path to be traveled. When the caterpillar is within range, you strike in a motion so fast that to the human eye it appears the caterpillar simply stopped moving. Your proboscis drives into the soft tissue behind the caterpillar's head, the point where nervous system tissue is most densely concentrated, and injection begins. The caterpillar struggles for between 2 and 15 seconds, depending on species and size, and then stops. What happens inside is why you are extraordinary. The proteolytic enzymes are breaking down protein chains in the caterpillar's internal tissue, converting solid muscle and organ matter into a protein-rich liquid you can draw back through the second channel of your proboscis. The caterpillar's body becomes a nutrient delivery system, providing you with pre-digested food without requiring you to chew, digest, or carry anything back to a nest. You feed from the outside while digestion happens inside the prey. When you are finished, you release what remains. The empty exoskeleton falls or stays where it was. You fold your proboscis back beneath your head and resume waiting. The National Geographic Society has described assassin bugs as among the most important beneficial predators in agricultural and garden ecosystems globally, documenting their impact on pest populations, including aphids, caterpillars, beetles, leafhoppers, and moth eggs. In environments where assassin bugs are present in healthy numbers, pest populations are measurably suppressed without the need for chemical intervention. This is the counterintuitive truth about the assassin bug that most gardeners never fully understand. The insect that delivers one of the most painful bites in the garden is also one of the garden's most effective defenders. Its bite is the price of its presence, and its presence is, for the plants around it, genuinely valuable. The pain of an assassin bug bite on human skin deserves its own discussion because it is significantly more severe than most people expect from an insect this size. When an assassin bug bites a human, either accidentally when handled or defensively when threatened, it injects the same salivary mixture it uses on prey. The proteolytic enzymes that dissolve caterpillar tissue begin working on human skin and subcutaneous tissue immediately, causing an intense burning pain at the site that has been described by researchers as out of proportion to the small size of the wound. The Royal Entomological Society has documented assassin bug bite cases in multiple species, noting that the pain response is typically immediate and severe, lasting from several hours to several days depending on the volume of saliva injected and the individual human's sensitivity. Some species, particularly the larger wheel bug of North America, Arylus cristatus, are documented as delivering bites considered by entomologists who have experienced them to be among the most painful inflicted by any insect on the continent. The wheel bug is worth describing in more detail because it represents one of the most dramatic extremes within your family. With a body length exceeding 4 centimeters and a distinctive gear-like crest rising from its thorax, the wheel bug is the largest assassin bug in North America and has been documented taking prey including small wasps, bees, and caterpillars substantially larger than itself. But within the Reduvidae family, your diversity of strategy extends far beyond the basic ambush approach. Some species within your family have evolved hunting methods that researchers describe as among the most sophisticated deceptive behaviors in the insect world. The bee killer assassin bug, Apiomerus species, has been documented coating its forelegs with sticky plant resin and using this coating to trap bees that would otherwise detect and evade a direct approach. The resin functions as both adhesive and camouflage scent masker, reducing the likelihood that bee chemoreceptors detect the assassin bug before it is too late. Other species in your family have evolved one of the most disturbing camouflage behaviors documented in any insect. Certain assassin bug nymphs in the genus Acanthaspis carry the dried exoskeletons of ants they have killed on their backs, building a constantly accumulating layer of dead ant bodies that serves multiple functions simultaneously. It disguises the assassin bug's own chemical signature from ant colony guards. It allows the nymph to move through active ant colonies without triggering defensive responses, and it creates a physical barrier between the nymph's soft body and any retaliatory bites or stings from its prey. Nature has published detailed studies on this behavior in Acanthaspis petax species describing the ant corpse backpack as one of the most complex multifunction camouflage systems documented in any predatory insect, combining chemical masking, visual disruption, and physical protection in a single behavioral adaptation. You were never designed to be comfortable. You were designed to kill things that don't know you're there. Some members of your family have, over millions of years, made a transition that researchers describe as one of the most consequential biological shifts in any insect lineage. Several species within the subfamily Triatomini, commonly called kissing bugs, have shifted their primary food source from other insects to vertebrate blood, including the blood of mammals and birds, including humans. These kissing bugs feed at night, approaching sleeping animals and piercing thin-skinned areas near the face, often near the lips, which gives them their common name, feeding without waking the host by injecting a local anesthetic as part of their salivary mixture. The consequence is not primarily the bite itself, which is often painless and unnoticed. The consequence is what some kissing bug species carry, Trypanosoma cruzi, a protozoan parasite transmitted in the bug's feces when it defecates near the bite wound. Causes Chagas disease, a chronic condition affecting the heart and digestive system that the World Health Organization estimates currently affects between 6 and 7 million people worldwide, primarily in Latin America, making certain members of your family among the most medically significant insects in the Americas. This is not aggression in the sense most people attach to the word. The kissing bug is not seeking to harm. It is feeding, the same biological imperative that drives all of your family's behavior. The medical consequences are a collision between its feeding biology and the presence of a parasite it carries. A relationship that evolved over thousands of years without awareness on the part of either organism of what it produced. The breadth of your family makes simple characterization impossible. 7,000 species means 7,000 variations on the same core plan. Some hunting garden pests with a precision that benefits agriculture, some carrying parasites that reshape human health histories, some wearing the bodies of their victims as armor, some trapping bees with resin, some delivering bites that entomologists rank among the most painful in the insect world. Does that diversity sound familiar? Within any sufficiently large group, whether of insects, of ideas, or of humans, the same fundamental design produces an extraordinary range of outcomes depending on environment, context, and the specific adaptations each lineage developed in response to its particular pressures. The tool and the outcome are never identical. The same proboscis that saves a garden can, in a different species in a different context, carry something that changes a life. You grow through incomplete metamorphosis, meaning you do not pass through a pupal stage the way a butterfly or beetle does. You molt through a sequence of nymphal stages, each one slightly larger and more developed, each one already capable of hunting, already carrying the same proboscis you will use as an adult, already patient, already lethal in the proportional way appropriate to your size. By the time you reach adulthood, you have spent your entire life refining the same set of skills you were born with. The patient waiting, the positional ambush, the proboscis strike, the chemical dissolution, the feeding. Adult assassin bugs in most species live for several months to over a year, spending their time in the same patient ambush that characterized every stage before adulthood. Some species are capable of flight and will relocate between hunting grounds when prey density drops. Others remain sedentary in productive locations for extended periods, returning to the same perch repeatedly because the same location that produced prey before is likely to produce it again. In a garden where you are present, caterpillar populations decline. Aphid colonies are periodically culled. Leafhoppers disappear from stems where you hunt. The gardener may never see you and may attribute the declining pest population to the weather, to other factors, to luck. You are the invisible mechanism behind outcomes people notice without identifying the cause. This is your most important ecological role and the one least celebrated. Not the terrifying bite, not the chemical dissolution, not the ant corpse backpack, but the quiet, patient management of pest populations in gardens and ecosystems that have no idea you are there, doing the work. You do not move. You have not moved for nearly an hour. And the caterpillar feeding on the leaf 2 centimeters from your face has no idea that somewhere in the evolution of your family, over 100 million years of refinement across 7,000 species, everything led to this moment in this garden, on this leaf where patience just became something else entirely.